Okay, so here is the first part of this tutorial, which is setting up your massings and getting them as construction geometry so that you can then use them for Rhino components, Rhino inside components and creating things, translating it into Revit. So what we're going to look at a lot is that there's essentially direct geometry imports, which are imports. Many of you have probably imported geometry from Rhino into Revit before. It's just a much more automated way of doing that in a way that you can update quickly and easily rather than manually importing all of those things. Importing stuff into Revit is necessary. It's not going to be possible to build everything that you want to do natively in Revit. It's just the nature of the beast. If you had a really sort of rectilinear project with not a lot of complexity, you could perhaps build everything, but most projects are going to require a little bit of importing. But then we're also going to be creating native Revit stuff through Rhino. So what that means is rather than importing geometry from Rhino into Revit, we're going to tell it to use a curve to do a floor slab, or use a curve as a center line of a column, or something like that. Draw a wall along a curve. There are ways that we can tell it to redraw the stuff directly in Revit so that it comes in as native Revit, but is originated in Rhino. So to do that, we have to create some intelligence and construction geometry in order to get this to work. So, all right, let's start with our model. And I'm going to use a geometry placeholder. We're going to bring a few things in, but most of this is going to be done within Grasshopper. So let me just get this a little bit better organized. I'm going to save my file here, make sure I don't override my finished one. This is going to be kind of messy, and the one I'm going to give you is cleaned up, but in the interest of time, I'm not going to clean this definition as I go. I'm just going to kind of keep building and building. I'll organize as I need and give you guys some tips for organization, but in general, the final version will be clean. And this one will be a little bit messy. So I'm going to use a geometry placeholder, and I'm going to call this entry massing. I'm going to copy these, and I'm going to do a podium massing, and then a tower massing. Okay, now that I have those, I'm going to set my geometry by my entry, set one geometry podium, set one geometry tower. So now I've got all of this done here, and I can actually hide these for now. So I'm going to hide my different massings, and now they exist within Grasshopper. And I'm going to start subdividing these down so I have the floor slabs for them. That's going to allow me to create my levels, it's going to allow me to create my floor slabs, and it's also going to allow me to use the slab as like a base for a column grid. It's also going to allow me to use the slabs and the faces of the massing as boundaries for my facade. So really everything's going to be built off the slabs. I might use some of these surfaces of the massing, but in general, I like to use curves as much as possible. So let's start by, I'm going to show you a few different techniques to get some floor slabs. So let's start with getting the floor slab for the entry. Super straightforward. I'm just going to go a contour component, and we'll use this a couple times. Make sure it's the contour solid. I'm going to take the entry massing, plug that in there. It's going to ask me for a start point. 0, 0, 0 is good because that's the base of the project. The normal direction 0, 0, 1, that's Z, so that natively is good. And then the distance, I'm just going to make this a slider. 0, and then I can use a less than sign and then put in my value 10 and then a less than, and let's say 25. So I get a slider that goes from 0 to 25 now. I'm going to plug this into my D, and I don't want more than one floor here. So if I go less than 20, I'm going to get 2. So I'm just going to set this for 20 for now. And then I've got my floor slab, polyline curve, nice and simple. In order to keep this organized, you'll see me do this a bit, is I'm going to take this and plug this into a curve component, and then I'm going to rename it and call it entry floor curve. So I can come back and reference this at any point and know what it is. I spelled entry wrong. Let me redo that. ENTRY. There we go. And then this slider, you're going to see, will pull some sliders over to the left as inputs. We don't really want this to be something that's edited too much, because we want this to be one big tall entry space without an additional floor slab in it. But let's say you decide that you want to change the height of your entry massing. You might want to come over here and edit this to make it clean. But we don't need that. We don't want the user to kind of manipulate that. We want you to kind of use the massing to do that. But the podium, we might want to chop up a couple more times. So what I'm going to do here is I'm going to copy paste this, pull this in, right? And you'll see we have actually, I'll rename this and call this Podium. Podium floor curve. We'll call it S curves. So we have more than one. We have 2 right now because they're 20 feet apart, and this is a 40-foot volume. If I bring this down to 19, you'll see we get an extra 1 there. One thing you'll notice though is it's actually not cutting at the bottom. And the reason for that is it's starting at the 0. We want it to start at the bottom of this massing. So we're going to have to do a little bit of gymnastics to get that to work. So what I'm going to do is I'm going to use a bounding box, and I'm going to show you guys a bunch of different techniques over the course of this. The bounding box is good in the event that the volume does not have a flat bottom, but we'll just use this for now. What is the geometry that we want to put in here? The geometry to contain, that's my podium massing, right? So now I have this bounding box which contains that whole massing. It's giving me a bunch of boxes. I'm going to go to deconstruct box, bounding box, right? And then my Z is going to give me my dimensions of my bounding box. So what I'm going to do is I'm going to do a deconstruct domain. I'm going to get the start and the end of that. The end is the lowest point of that box. That's the bottom face. That's the Z dimension of the box. And I'm actually just going to construct a point. Construct point. My X and my Y are going to be 0, and my Z is going to be that. So now I have a point that exists in space 20 feet up. There's that point. And so my start point for this is actually going to be that. And now I have curves every 19 feet starting at the bottom. So what this does is allow, if this box moves up or down, we'll always be contouring from the bottom of it. And we're going to use this same technique later. I'm going to show you another technique that I actually used in my other definition. This is probably a little bit quicker, but there's more than one way to skin a cat, as you'll see. Okay, so now I've got my this. The problem is I actually want this to be 20, and I have 2, and I want this top curve. So down here I didn't grab this top curve because the top of this bottom box is basically the bottom of this box, right? But here, and so let me actually show you this too. I can right click on those and turn the preview off so I don't get too many things just stacking on top of each other. This gives me the ability to, so I want to get the top of this box and all of these, right? So what I'm going to do is I'm going to show you guys another technique, which is I'm going to take this massing, I'm going to go to deconstruct B-rep, and I'm going to grab this B-rep, boundary representation, podium massing, and then I'm going to take all the faces and I'm going to take the area of them, not because I actually want the area, but the area will give you the centroid of that. And then I'm going to evaluate those points. Sorry, it used to be called evaluate point, now it's called deconstruct point. It has been deconstruct point for probably like at least 8 years, but I remember back when it was evaluate, so I'll sometimes try to find it there. So I'm going to plug all my center points into here. It's going to give me all the z values of those points, and I actually want the highest one. So I'm going to sort these points by plugging into a sort list k. I'm going to also sort, this is asking for a set of values to actually sort in the same order that I'm sorting those. This needs to be a list of numbers, or it can be text and it'll sort it alphabetically. This can be anything, but it's going to sort it in the same pattern that it sorts the other values. So I'm going to take my faces and plug them in there. And I want the last item because I want the highest face. Let me pull this over, give myself a little bit of room. So I'm going to do a little trick and do a reverse list, because that's going to flip it, and I'm going to pick list item. These are all components you're going to see me use a bunch of times, which will give me an item at an index in a list. This will give me the first item, so that is my top face, right? I can then do brep edges, plug this in. This is going to give me all of the naked edges of that surface, and I'm going to join those curves. So now what I have here is the roof of the podium. So I'm going to create another placeholder, call this podium roof. Podium roof. All right, and I'm going to pull these over because I'm going to use that curve, I'm going to use my floor curves, and I'm going to use my roof curve. All right, so we're getting close. We're getting some good stuff going on here. Let me get this a little bit better organized. I'm not going to make it super clean, but I'm just going to make it so I can actually work. I want to be able to control the floor-to-floor height of the podium and this one we're going to leave here, but the podium is probably something that we want to vary. So let's call this floor-to-floor podium. And again, this will be able to update. Let me hide this. Great. So now what we have is all of these, and I'm going to hide these for now so you can just see the curves, because we've gotten those taken care of. And this is, remember, this is parametric, we can adjust. Now, it's important to note that, this is not evenly spacing them. This is setting them to be exactly 20 feet. For the tower, I'm going to show you guys another trick of how do we get it to actually be spaced evenly. We're going to try to set a target floor to floor, but it's going to space them so that it fills the volume, or it fills the massing exactly what we want it to do. Okay, so let's start working on that one. So here's my tower massing. I'm going to do a contour on this one too, and I also want to start at the lower port. So I'm going to do I'll show you guys how to use this deconstruct brep as an alternative method to get the lowest face. So I'll go to tower massing, plug that in. I'm going to use this area, deconstruct, sort, all of that. And I have to plug my face into the area, and then my face into the, that goes into there, my face goes into the area, and then my face goes into here. But rather than flipping them and reversing the list, I'm actually just going to take this, and now I have my bottom face, and I'm actually just going to use an area on that, and then I have my point, which is my lowest point. So I can then come up and grab my contour, and I'm going to change some of these around because I want to contour this surface. The point at which I start is this new centroid here, and then I have my floor to floor of my volume. Now this right now, you know what, I'm going to copy and paste this because I don't want this, I want to be able to control these differently. Usually the tower height floor to floor is going to be different than the podium. Let's say the podium is like maybe commercial space or some big retail space or a hotel lobby, hotel amenity. Maybe you want 20-foot ceilings or 20-foot floor to floor. Your tower is probably something more like 12, maybe 11 and a half. So that's good there. But let's say we want 11-foot floor to floor, right? What you're going to see is we have this little discrepancy here, and that's what we're going to try to eliminate right now. So what I'm going to do is I'm going to actually take the area of all these contours, right? Or you know what? Rather, I'm going to take the first item in the list, the centroid, and I'm going to reverse this list. Or you know what? I think I can actually do this. I can add a plus and get -1 item in the list, which is the last item in the list. Yeah. So that's my top surface. And then I'm going to actually do deconstruct point again. Centroid. Centroid. And I don't want to measure from point to point because if I actually do a line from point to point, and do a length of that curve, it's probably going to be, yeah, it's greater than 3. It's just slightly more than 300, but it's not going to be perfect because they're not, it's angled. It's not a straight line. So I actually just, what I want to do is subtract the z value of my highest point from the z value of my lowest point, and I get 300. So that's exactly kind of what I want to divide. But what I'm going to do is, yeah, I want to divide my overall floors by that, right? So I'm going to divide that by this 11, and that's going to give me 27 floors. So what I'm actually then going to do is do a round 27 floors. So it's going to give me the closest, right? It's going to round up if needed or round down when needed. And then I'm going to actually divide again. I'm going to divide my 300 by my rounded number, which gives me 11.111. So now if I come into my contour distance, it's actually giving me exactly enough contours to fit the tower. So rather, it's not going to be, this is my, let's call this target floor to floor. Tower. It's not going to give me the exact dimension that I want, but it's going to give me an equal number of floors that are spaced evenly to fill the tower. That's close to that. All right, so now we've got all of our floors set up. There's a few more things I want to do. I want to get a list. I want to get a list of curves, which represents every single one of my floors. But I have to kind of be a little bit selective. Like I don't want this bottom curve here because this is not the floor of my tower. The floor of my tower is the roof of the podium. I mean, architecturally, or with a little construction detail, that might not actually be the case, but for the purposes of what we're trying to do, that's how I want to do it. So we have to do a little bit of organization to get the list there. And I'm also going to make these tower curves a little bit different to kind of make the tower geometry a little more curved, make it feel different than the podium. So we're going to do a little bit more to these to get them ready before we start plugging them into Rhino. Or I'm sorry, before we start getting them ready for Revit. So in order to do that, let's first work on these. Curves for the tower. So what I'm going to do is I'm going to offset these in a bit and then fillet them to get a nice curve on them. So I'm going to offset the curves, not that component. Let's just use the regular. This is the regular Rhino one. Offset those, and I'm actually going to offset them in actually out like that. A little bit is okay. Yeah. You know what? We're going to offset them in for the columns later. So let's just keep this as is, and I'm going to do a fillet. We can adjust it later if we need to. But I'm going to do a fillet, and I'm going to do a curve radius. So I'm going to do, I think I used like a 3, but I'll show you. We'll do a slider. 0 is less than 3 is less than 6. Let's see what that does. Plug this in. So now you can see the fillet of those. Let me hide these and hide my massing to give us a little bit more. Pull these over. Let me hide some of this stuff here. And I'm going to hide my tower massing. Okay. I'm going to up this a little bit. Let's make this like a 5 or a 6. Yeah, that looks pretty good for now. We'll keep it at that. Yeah, let's do that. All right, and then what I'm going to do is start to merge this into one group of curves. So I'm going to use a merge component. One thing we haven't talked about to this point is flattening and grafting. This has to do with data trees, and data trees are really, really complex on their own and could be the subject of multiple videos. But just to kind of show you what's happening, this is data with one branch. This is data with 2 branches, because each contour operation is creating a new tree branch. I could flatten this, which now actually gives me data with 1 branch with 2 items. But maybe this preview will help. So I actually have just one, even though there's multiple items, there's only 1 branch of data. So if I take off that flatten, at some point there's an operation which causes it to break off into 2 branches. And so it gives you that history. Sometimes we're going to want things in branches, which is, grafting will do that for us. If they're not, other times we want them flattened. So I want all of these curves to just be in one big long list of floor slabs, because I'm going to kind of just treat them all the same. But then, as you'll see down the road later, we're going to come back and actually use them differently. So let me get these all into one flattened list. Let's call this curved floor slabs. All right, and then I'm going to merge all these. So I'm going to plug this in, I'm going to plug this in, I'm going to plug this in, and I'm going to plug this in. And it's important to put them in the order that you want them. But then I'm also going to flatten all of this, because actually let me show you with the param viewer. It's going to be sort of a messy tree right now. Right, like it's got like all these different branches, and some of them are longer than others. It's kind of all over the place. So if I come here and I flatten, 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 I should have kept the param viewer on, but let's just show you how this looks now. This is just one branch of data. There's actually one thing I forgot to do before I did that. I want to remove the lower floor slab here. So I'm actually going to flatten this back here. Or you know what, let me flatten it here. And I'm going to do a split list. I'm going to plug this list in. I'm going to split it at item number 1. And then I'm going to have my closed planar curve, that's my first item, and then the rest, I'm going to plug that in. So now if I click here, I actually don't have that curve, which is good. I don't want that because that'll sort of a duplicate slab as the one here. But these are all the slabs that I want for, all the curves I want for my slabs. So all this is feeling good. I've got my curve slab, I've got everything else. So the last thing that I think I'll do now is, you know what, I'll handle it in the next video because it's kind of part of the levels operation. So we'll see you there.